Hello everyone and welcome to this channel. In the previous video we have covered how to install the compiler and the IDE for Fortran. We have also covered the input-output statements and variable declaration. In this video we are going to explore Fortran a bit deeper and see how we can generate some data with Fortran and then plot it using GNUPlot. I have already written the code, so let me explain it to you. In the first line, we are just starting the program. In the second line, there is the new statement called implicit none. It allows you to stop variable declaration Fortran allows you to use a variable without even declaring it, like Python or JavaScript. However, that often leads to errors in program, so we use the implicit none to switch off that functionality and declare every variable at the start of the file. In the next part of the program, we are defining some variables I and x. In the next line is important. Here we are declaring a parameter, in other words a constant value called pi. Python or other languages have inbuilt pi value. However, Fortran does not have an inbuilt constant pi. So we have to just set its value as 4 times tan inverse 1.0, which will be pi by 4. In the next line, we are doing something new. We are opening a file called sine.dat, and this is the syntax. The unit equal to 1 means that this is the first file opened. Fortran uses unit numbers to identify files. This statement associates the unit 1 with the file sine.dat, which is our data file, where we are going to write the value. In this part of the program, we are using a loop, like the for loop in C or Python or other languages. In Fortran, we have the do loop, which does exactly the same thing. Here the loop variable is I, which we have already defined. It starts from 1 and goes to 360 in steps of 1. Since we have not mentioned the step size, the value of I increments by 1, which is default. Unlike C, where we have to use a statement like I++. In the next line, we are converting degrees to radians, since the sine function we are going to use does not takes degrees, it takes only radians. This line is a bit difficult. This is just our old write statement. Unit equal to 1 tells the write statements to write to the file we have previously opened, sine.dat. FMT is a format string which we will explain in a later video. It just does what? It prints the values of x and sin x separated by 2 spaces, 2x. Then we are closing the do loop, and finally we are closing the file with the appropriate unit number. If you do not close the file, then it will cause memory leaks in the system. Okay, so let's proceed to actually compiling the program. Compilation finished successfully. We'll open the terminal. Then we are going to run this file. Since the file name is data.f90, so the executable name will be just data. We run the executable by /data. Let us now open the generated file in GNU to see what we have just done. The file is named sine.dat. Let us open this file in GNU. Here is our generated file. You can see that it has exactly 360 rows. The first column is the angle value in radians, and the second column is the corresponding value of the sine function. 0.0175 is just 1 degrees. Now, to see something nice and graphical, we need the program GNUPlot. It is a plotter for data files like this. Files following this structure can be easily plotted in GNUPlot to see a visualization of the result. So for that we need to install GNUPlot. I have already GNUPlot installed, so I will just show you how to use it. In the terminal we will write GNUPlot to start it. This gives us the GNUPlot command line interface. Now to plot the file we need this command, plot sine.dat with points, point type 7, point size 0.5. With points means that each of these rows of the data file will be plotted as a point, and those points will not be connected by lines. So point type 7 means this selects one of the GNUPlot's different types of points. GNUPlot has lots of different graphics for points. It selects the 7th graphics, and we set the size of that graphic to 0.5. Now let us run this. And here you can see a very nice plot of the sine function from 0 to 6 point something, which is just 2 pi, since 1 pi is 3.14 about. So this is today's video. Hope you liked it. Please consider liking this video and subscribing the channel for further updates. Thank you for watching.